Hello! Welcome back to Stray Monkey Physics. I make it Stray Monkey because years ago somebody took the name Stray Monkey and they kind of twiddled with it a little bit and they turned it into Stray Monkey. So my YouTube channel is Stray Monkey Physics. I thought it'd be kind of fun that way. Today what we're going to do is go back over the inclined plane. Go over the basics and then we'll talk about what happens when you attach a pulley over here at this top right here. We're going to hang some weight right down here on this side right here. And we're going to hang a weight over there and see what happens. But first, we're going to go over the basics of the inclined plane, which we've already been over, and make sure we get that straight in our minds before we start playing around with the thing. Okay? So, here we go. So here we have our basic inclined plane. Okay? We've got our mass up here. We've got a 25-degree angle, and we're going to say no friction. Okay? No friction. Better put that somewhere up here. No. Go there. No friction. Okay? It's not hard to do with a friction on it, but do one basic thing at a time. Alright, so we got our mass. It's sitting there on our inclined plane. And what is the one force? What is the one force acting on that plane acting on that mass right there? Gravity. That's right, gravity's pulling that thing. So we're going to draw our gravity or weight. Remember, when gravity pulls on a mass, that's called its weight. We're going to draw that vector in there. So we're going to draw a nice, great, big vector arrow straight down. And remember, this is one of the skills that you've got to be able to do, is draw all the vector and the components of a force acting on a mass that's on an inclined plane. So these are good step-by-step things to learn. Now, the first one you draw, of course, is gravity. It pulls things straight down. To be smart, it's a good idea to draw it really big. Okay? Because when we break this into components, you don't want little tiny little things. So draw the first force of weight really big. Okay? So I'm going to say force. I'm going to put a little W for weight. And that's always mass times G. Acceleration due to gravity. Okay? Now, that part hopefully you remember. Now, what this inclined plane does is it's going to break this component. Okay? It's going to break this vector right here. Excuse me, not component. It's going to break this vector right here into two components. Okay? And what we learned before, the two vectors it's going to break it into is, first of all, if there's no friction, you let go of this box, it's going to come sliding right down the hill here. Okay? It's going to slide right down that incline. So part of that force of gravity and the weight pulling it straight down pulls it down the incline. That's the whole reason why our little mass here is going to go down the incline. Okay? Now what we're trying to do is show that force right there, and that's going to be the force. And since that force right there is parallel to that inclined plane, we're going to call that force parallel. And the symbol for parallel is two straight vertical lines. Looks like an 11, but that's the mathematical symbol for parallel. Now the other force component is, and draw this real careful, it's going to be 90 degrees. It goes straight down into the incline, like that right there. Okay? And that one is the force, and since it is 90 degrees, they call that the force perpendicular. And this simple they use in math to represent perpendicular. Looks like a capital T, but it's upside down. Looks like that. That's the force perpendicular. Now, if we drew this right, remember our add vectors, tail, head? If we picked this force perpendicular up, and we moved it over here, so it would be tail, head, this vector should fit right over here. So if I pick this thing up, move it right over here, it should, can't draw this sideways, it should line straight up right there. Okay? And same thing, if I wanted to add it the other way, pick up my force parallel, pull it up and put it right down here, it should fit right there. So, does that look like? Yeah, that should look like a really nice rectangle. I got close there, it's a little narrow on the bottom, but we're pretty close. Okay? So, when you put a box on an inclined plane, that force of weight pulling straight down to the center of the earth gets broken up into two components. One component, called the force parallel, pulls it down the incline, and the other force goes straight 90 degrees right into the surface, called the force perpendicular. Now, if you take a good close look at this triangle right here. This triangle right here looks just like this great big gigantic triangle of our incline. And they are what they're called similar triangles. And similar triangles means that they don't necessarily have all the same length sides, but all the interior angles of the triangles are exactly equal. Okay? So that means this little wedgy 25-degree thing right here, that's also the same as this angle right here. Okay? So this angle right here and this angle right here are both 25 degrees. And this triangle over here, that's made with a force perpendicular, it also has the exact same characteristics. So, and it's also a similar triangle. So that means that angle right there is also 25 degrees. Okay? So this angle right here is equal to this angle right here, which is, that's too small to see, I'm going to get rid of that, is equal to that angle right there. Okay, so we got three similar triangles. Next thing we're going to do is we need to find, okay, we need to be able to calculate, if we know what the weight of our object is, then we need to be able to calculate what the force parallel is and what the force perpendicular is using our trigonometry. Okay? So, let's come up with a mass. Let's say the mass in this box right here is 10 kilograms. Okay? 10 kilograms. So, the first thing we can do is calculate the weight. Calculate the weight of this object. It'd be the mass, which is 10, times gravity, which we're going to say is 9.8. So the weight of that mass right there on our incline is just going to be 98 newtons. Okay, 98 newtons. Now from that, we can find out what our force parallel is and what our force perpendicular is. Okay, so let's go figure out our trig. Now, we're going to go and find the force parallel first. So if I'm trying to find this side of this triangle right here, this is my 90 degree right here, you can probably see that. Okay, and we know this is 25 degrees. And we know this long hypotenuse right here, we just calculated it, it is 98 newtons. So, in order to figure out what trig to use, sine, cosine, or tangent, you got to pick a corner. It's best to pick the corner that you know, which is 25 degrees. And let's see, if we pick this corner right here, then we know the hypotenuse, and straight across from that one, or opposite of it, is the force parallel. So which one is it, sine, cosine, or tangent, that has opposite and hypotenuse? That would be the sine. So we write down sine of any angle is always equal to the opposite over the hypotenuse. Now we just plug in the numbers. The sine of 25 degrees is equal to the opposite, which we don't know, which is force parallel, divided by the hypotenuse, which is 98. Multiply both sides by 98 and solve for force parallel. I need a calculator. Just happen to have it. That won't work. It never fails, man. We have a calculator. And we have 98 times sine of 25 degrees. Make sure you're in degrees mode, and we get 41.4. 41.4. And don't forget, that's a force, so the units, it's going to be newtons. 41.4 newtons. Now, to find the force perpendicular, we're going to use this triangle right here. And we're going to pick that angle right there because we know that one to be 25 degrees. So this is 25 degrees. We know the hypotenuse of this triangle And this time we're looking for the side of the triangle that's right next to the angle, or adjacent to the angle. So if we've got adjacent and hypotenuse, that means you got to use cosine. So to find force perpendicular, we're going to use cosine of theta is equal to, the cosine of that is the adjacent, which is force perpendicular over the hypotenuse, which is 98 newtons. So that means force perpendicular is going to be equal to 98 times, that should be cosine of 25 degrees. Forgot to put that in there, sorry. So force perpendicular is now going to be 98 times cosine 25 degrees, which is 88.8. And the units for force is newtons. Okay? So now we have figured out our components, we know our weight, we know everything we need to know. Now, the next step is we want to do is if this truly has no friction and you let go of this box, it should slide right down the incline. Okay? So what we're going to do is figure out what is, when this thing comes sliding down this incline, goes down there, what is the acceleration of that box going to be? Okay? What is the acceleration of that box going to be? And that'll be our next video.